All right, so this lesson is going to deal with borrowing money. So it's the opposite of investing. So this is going to be found on page 63, and it has various layers to it. So chapter 2 deals all with borrowing. We dealt with investing so far, even though with investing there was a time where we also withdraw money, and so that affects our payment. So there are some similarities here. Some of the terminology, I just need you to know what it is. Collateral, right? It is basically a security against the loan that you're taking. A mortgage, what is a mortgage? It's usually a loan towards real estate, to purchase real estate. So it is a bigger amount, and it's longer than just a regular loan for a car or just a personal loan for a smaller purchase. It can involve a single payment. So you could have a loan where you borrow a bunch of money and then you don't pay until the very end when the whole amount is due. So it will accumulate interest over time. Or you can make smaller regular payments as you go along. That's probably the most common, most preferred way of doing it. With each payment period, right? So this is, I'm going to give this a different color here. Okay. So with each payment period, the interest rate decreases while the principal paid increases. This occurs because each payment decreases the balance of the loan. Okay. Each payment decreases the balance of the loan that you owe. Okay. So the interest is just charged on what remains, the remainder on the next payment. Okay. So the payment amount stays the same. Okay. So I'm going to add this to the side. Like if this is your payment, okay, this is payment number 1. Okay. And let's say it's $100. Out of the $100, it stays $100 the whole time, but it could be that, $80 is principal, like that actually from the 180 goes towards paying off your loan, and 20 is what we consider the interest, right? And so as you go along, your second payment comes around, there's going to be a bit less interest charge because you owe less, right? There's a big amount that you're trying to pay off. This is what we call the loan, okay? And you're trying to pay that off, so the principal, right, the 80 goes towards it, then you owe a little less. So payment 2 comes along, and it might be that, right, it's 81 now that you pay off, and this is just 19. And this varies, it changes, and it can be calculated exactly, but that's the idea. When purchasing a car or a home, a down payment is usually paid, okay? A home for sure, okay? 5% down for a house, for a mortgage is a minimum in Canada, 5%. The other thing is you need to be aware of credit cards. Credit cards are just like loans, so it's basically, right, a card that when you make purchases on it, you owe a bunch of money, right? So it's basically a loan that you get to use whenever you want, but you don't have to use up the entire amount that's on it, right? They're just crazy interest rates, anywhere between 18 to 33% per day. That's compounding. Okay. Savings account make the least amount of interest. Mortgages charge even more interest than savings, and credit cards charge the highest interest rate. Not so important, and that can vary. When using the TVM solver, okay, the number of payments and the number of compounding periods are often different. And I mean, I don't need to tell you that. You just have to pay attention. Okay? PY and CY can be different at all times. Okay? N is the total number of payments, not compounding periods. Just remember, N is always years times PY. And if you want to find the number of years and you solve it, you just have to divide. Sorry about that, to be continued here. How can you save on interest? That's going to be a big question here, right? But these are factors that affect the interest charge. It's the interest rate, the compounding frequency. Like let's put it this way here. To save on interest, copy this down. Okay, to save on interest, I'm going to put a spin to this. We would like to, right, decrease the interest rate. We also would like to, if at all possible, decrease the compounding frequency. So let's say you had a loan that has a weekly compounding rate. You would want a monthly, because that would be only 12 times a year, versus weekly would be 52 times a year, the calculations made. So you want to reduce that. It's the exact opposite of investing. The payment values are increased, right? So if you make your payment a bigger amount, you're going to pay it off faster, which is going to save you. Payment frequency is increased, like how often you pay. So this is the PY, right? Here you want CY to go down, but you want PY to go up, payments per year. If you decrease the term, so instead of 5 years, right, you drop it to 4 years, you should be able to answer. If I ever ask you how could someone save on interest paid, you should be able to draw from one of these. Interest rate, decreasing the interest rate, yes, it is possible, but most of the time you kind of shopped around and you can't change that a whole lot. So I would like you to draw from the other ones if possible. In this particular lesson, I will not talk about lease, and I will leave equity for now because that has to do with mortgages. Appreciation and depreciation, I do need you to know that part. So let's highlight that. Appreciation is if something increases in value over time. So it could be artwork, it could be an old-timer vehicle, gold, house, and so forth. And then there's depreciation, where an asset decreases in value over time. So especially a brand new car driving off the lot the first year. Both are usually expressed as a rate per annum, right? So per year, depreciates at 1.5%. And I'm going to give you formulas for that. It ends up being an exponential function. Either way, one is increasing, one is decreasing. So let's go over to 64. Okay. And here, I'm just going to give you some very helpful formulas, most of which, if not all of which, you already know about. But there is the sum of interest, start and end. Okay, it's the amount of interest paid after n payments, or whatever, however many years go by. You would just multiply that by py to figure out what n is, right? So start is usually 1, end, it depends on the year. You want the total amount, right? Or do you just want something, if it's a 5-year loan, do you want to know after 2 years? If it's monthly, this would be 2 times 12, then the end would be 24, so from 1 to 24, and so forth. Again, can't be used, star, can't use if n is a decimal. Okay, that's a big if there, you can't use that one. And you have to use a formula, which I'm going to show you. Principal paid from 1 to n is the amount of the loan of the present value that has been paid back after n number of payments. Balance, this one is going to be used a lot. Balance n, just like before. It's the amount of loan owing after n number of payments, right? So it's balance. What is this principal here? Every loan, okay, when you owe it, so you may want to just look at it for now. If this is your loan, and let's say you borrowed $1,000 day one, 5 months go by, it could be, right, after 5 months, sorry, you would like to know how much did you pay off. You check your balance, right, and you have 800. What happened here? How much principal has been paid after n number of payments? The principal here would be $200, okay? That's how much principal was paid off. I don't use this one a whole lot. What I normally do is I look at my balance, okay? I figure out the balance owing, and then I just subtract it from what I started with, and then I know how much principal was paid. So I could do balance after 5 months. Oh, it's 800. I started at 1,000. Subtract them, and you get your principal paid. So I don't use this one a whole lot. That's why I'm not going to highlight that. But in a sense, the present value, which with a loan, right? When we're dealing with loans, the present value is your loan, the amount that you're borrowing. It would be the principal paid plus the balance owing. Okay, so look at it here. This is your balance owing after 5 months plus the principal gets you back to the loan. Okay, so that's the idea here as well. Cost of the loan is the interest charge over the term of the loan. Can you please write this down? That's the finance charge as well. So on your study sheet, if you're making it already, you should have an investing side of finance and a loan or borrowing money side of finance. Interest on the loan would be the total payments you've made minus the initial loan value. Okay, and here is the formula that I would suggest. So this is basically the finance charge formula that I would say you should have on your study sheet. And maybe if this doesn't mean much to you, have the previous line as well so that it explains what it is that you're doing. Okay. And here's the equity of a house. It's normally the market value of the house, what you sold it for. Let's say it's 500,000, and how much you owe. Let's say it's 100,000 at the time you want to sell. Equity is going to be that difference. Skip for now. I'm going to come back to that later. Appreciation. I want you to have these two under loans. It comes back later for equity. Okay. If something appreciates, right, it goes up in value or depreciates. Either one, we use the following formulas. They are very similar except for if it's appreciation, there's a plus. If it's depreciation, it's a minus. Okay, so an example, you have $1,000 gold collection, appreciates at 3% per year. What's the value after 4 years, let's say? So it's a quick example here so you could use it. So first of all, it appreciates, tells you that you're going to have to use this one right here. And so market value in the future is going to be equal to the initial value of your gold collection, that's that one right there, plus 1 plus 3%. So 3% is written like that, to the power of 4. So that's really 1,000 times 1.03 to the power of 4. I don't have my other calculator here, but you would essentially go 1.03 to the power of 4, right? Multiply that by 1,000. And so in 4 years' time, your gold collection, because it's appreciating, would be this. Okay, you would have gained 125.51 cents. Okay, so here, just a little visual for how this works. So every single payment is split into a principal portion and an interest portion. And this line changes as you keep paying off what you owe, right? Less and less of your payment is comprised of interest. But if we zoom into every single payment, there is a principal portion that goes towards paying off the loan, the amount, the mortgage or the loan that you've taken out. So that's this bar right here. And every month or every week or bi-weekly, you slice off some of it so you owe less, okay? So what the amount that you were to owe is what we call balance. So we go years times PY. Total interest charge, then, that's something that the bank puts on top of what you borrow. Right? So this is the loan, and over time, they're going to charge you some interest, right? And it starts accumulating. So if you follow this interest every month, let's say, you're paying interest, you're paying interest, you're paying interest. On what? On what is owed here. Okay? And eventually, you fill up this portion here. If you add up all the interest you've paid over the entire loan, that's what we call the total interest charged, which is found by using this formula right here. Okay? So you take all of your payments, total paid to the bank, right? And we subtract the present value, like the loan you took from the very beginning, and that will leave us with that interest portion right here. So it's very busy, very convoluted. If you were to at any time want to zoom in and say, like, how much interest did you pay after, let's say, the first 5 months, you go zoom, sum of interest, start, end, right, and figure out that. Total interest, you would simply go 1 till the very end, like whatever n is, and it'll give you the entire interest charged. Right? So that's what that entails. And future value for loans is usually 0, right? We want to own nothing. Okay, let's jump into our example here. I will do the first one, which is very rare. That's why I put down rare. This is an example where there aren't regular payments being made. Okay, so example 1. Grab your TVM solver. I'm going to do that too. Trina's employer loaned her $10,000. One second. All right, so sorry about that. Lots of interruptions. So example 1 here, let's go over that here. No payments made there, okay? So it's a little bit of an interesting example, but it can be done. Not very popular. So here you go. There's a fixed interest rate, 6% compounded annually to pay for textbooks and tuition. So I guess sometimes student loans for students, there's an amount you take out to pay for tuition, and then you may have to pay it back at the end at some sort of interest rate. Sometimes it has been 0, so it varies. The loan has to be repaid in a single payment at the end of 5 years. So emphasis on the single payment. Okay, there are no recurring payments. Maybe I should make a note. No recurring payments. Reoccurring, right? So that's what that is referring to at the end of the 5 years. So let's answer that. And of course, if it's finance, chances are you're going to use the TVM solver. And let's see what we can fill in. We're told the compounding periods, compounded annually, so that means once a year. Payments per year, PY. There are no recurring payments, so this is 0. And it still stays, the rule still stays the same, that CY and PY are the same. Future value, normally we want the speed down to 0, okay? Normally, when there are payments being made, you eventually want this to 0. In this case, we want to know, this thing is just going to sit and accumulate interest in a bad way. You're going to have to owe it, right? You're going to owe that amount at the end. So present value, you're getting 10,000, right? So you're getting 10,000. This is positive. This is what we're going to solve for. This is the exception, not the normal example, but I'm just going to show you one example so you're ready just in case. Over 5 years. So we go 5 times 1 is just 5. So we filled in everything except for 1. Of course, you put 0 in the meantime on your calculator. I'm just going to tell you what that amounts to, okay? I should probably go through the motions here with you. 5, 6, 10,000, 0.0011. Okay, so then we solve for future value, and there it is. It's 13,382 and 26 cents. Okay, so you haven't paid anything along the way. It's just at the end one lump sum payment, and so you paid 13,000 and then some back. Okay, so B, how much did the loan cost her? This, the cost of borrowing is interest. Interest paid, that's what they're asking for. Okay, so interest paid, you would use the formula normally. Here is the formula that I want you to use. Interest on loan, it's payment times n minus present value. That's normally what you want to use, but in our case there is no payment. So how do we do that? Sorry. In this case, it's just as easy as subtracting future value and present value. So it's almost like still an investment question. So 13,382.26 minus 10,000. So that's 3,382.26. Okay, that's how much interest you've paid in this particular case. I think I'm going to make a slight change here. This works every time. I want you to rewrite that formula, and we're going to go to page 64 here to make a change to that, because this one works every time. Let me just check. Sorry about that. There's the bell. So in this case, payments would be 0. So this is still coming back from investing. Okay, this formula right here. When there's a payment, we're going to use the other one that was on the previous page. So I'm not going to make any changes on the previous page. I'm just going to leave it like that. Let's do the next part. C, what would you expect to happen to the cost of the loan if the interest rate was compounded monthly? Okay, so C. When borrowing, and all else is the same, meaning what we're borrowing, the interest rate, and all that, a higher compounding amount period per year results in, let's see, you fill in the blank if you're watching this. What do you think is going to happen if the compounding is higher? Because right now we're at once per year. If it's monthly, it's 12 times a year. So a higher compounding period results in more interest paid. So monthly would cost more in interest. Okay, so there we have it. Right, so annually is 1, monthly is 12. Okay, so obviously 12 times a year is going to result in more interest having to be paid to the bank. Let's do an example where we have payments. Okay? Lars borrowed $12,000 from a bank, and it's 5% compounded monthly to buy the new jet ski. Lars negotiated a regular loan of $350 at the end of each month until it is paid off. How long will it take Lars to pay off the loan? Okay. Oh, by the way, I didn't mention that. But for the question up here, in my opinion, the easiest, since n is not a decimal, you could have used this one. Sum of interest is 1 to 5. You want the total interest, so whatever is an n, is what goes in here, and I've already tried that. You do get this amount as well. Okay, so either way you can find the interest. So it's in the next example where you will not be able to use that sum of interest, because n, especially when you have to solve for n, you end up with a decimal. So how long will it take for him to pay it off? We go NI, PV, PMT, PY, CY. Did I get it all? Okay. Let's fill in what we know. The compounding is monthly, so that's 12. The payments, the recurring payments, are 350 at the end of each month, so we have monthly payments, so 12 times a year. Future value, you want to pay it off, right? Eventually you want it 0. The payment is leaving you, right, going to the bank to pay off your loan. Present value, we have to watch out for a down payment. Okay, if there's a down payment, we would take it off right here. If you ever see a down payment, let's say they had $2,000 to put down towards this purchase, we would go 12,000 minus 2,000, and then what you're borrowing is really just 10,000. Okay, obviously you're going to pay it off faster in that case. Interest rate is 5%. N is what we're solving for, so let's go ahead and do that. This is 12 and 12. 0 for future value, negative 350. Present value is 12,000. 5. And N is what we're solving for, so you get 37.0731. And I'm going to write down all the values here for this. 4 would be fine there. So how long, not in what year, not how old is it, just how long. In 37.07 what? If you just grab that number, it's based off of whatever is in PY. And this is 12 times a year, which is months. So you could say in this many months. Why is it 37.07? Here is why. You're going to make 37 payments of exactly 350, and then there will be a little bit left over that you have to pay. So you're basically going to pay, watch this, 0.07 in this case, times 350, with like 0.07 of a payment of 350. So your last payment would be 2450, if you can see that. Okay. Your last payment. So there we go. So in this many months, or if you want years, right, you would go 0.0731, or let's go to 4 decimals times, oh no, my bad, sorry, I'm rushing here. You could do that to get it to days. But if we wanted it in years, to time in years, or we go 37.07 divided by 12, right? Divided by whatever PY is. That gives you 3.09 years. Okay, so you could do in months or in years. It didn't ask, it didn't specify, but here it is. That's what you figured out. B. What would be the balance owing after 1 year? How much would you owe, right? They don't have to say balance, but what would you still owe after 1 year? And so all we would do is 1 year times whatever PY is, which is 12. That's just balance 12, right? So you grab your calculator, and this only works if you have this solved in your TVM solver. So you want to quit whatever you're doing, then go apps, finance. I go arrow up right away, go to balance, and that's 12, right? So after 12 months, you still owe 83.16 and 34 cents. Okay, so that's how much you owe after 1 year. What would be the balance owing on the final payment? This is a bit of a curveball. on the final payment, right, 37 payments of $350 and 0.07318,509 payment of, okay, of 350. That would be the equivalent. I'm going to go up in here. I'm just going to go 0.07318,509 times 350. Can't see that. 0.07318,509 times 350. So the last payment is just going to be $25.61. And that's sometimes, you know, when you sign your contract for the loan, it's going to tell you that. It's going to tell you that your last payment might be just a little amount owing still at the end. D, what was the total cost of the loan? Can't use sum of interest, okay? Can't use sum of interest for this one. So you have to use this formula right here. Total interest is N times PMT minus whatever the present value was. So we have 37.0732, right? That's my N times the $350, and you subtract what you started off with, which is 12,000. Okay, so you basically, let me clarify this. This is how much you paid the bank over the course of your loan. You paid them back, and obviously this amount is going to include what you borrowed, the 12,000, plus any interest that they've charged you along the way. So when you subtract what they gave you to begin with from what you've paid them throughout the loan, that's how you know how much interest you've paid. So you get, here we go, 12,975.62 minus 12,000. So you will have paid $975.62 back to the bank. Okay. Can you see that? Let me see on the screen here. All right. So what I want you to try, I'm going to ask you to try examples that are on page 66 and 67. Okay. Page 66 to 67, there are some interesting parts in there that are worth trying out. You're gonna have to try to figure out, like, how do I use my calculator and in particular TVM solver to answer this. Okay, maybe I'll give you a few heads ups here, if that's even a word. I think I'm just going to let you try that. Go to 67 at the bottom here. And I'll post the answer key to this, but option B has, there's a fact that you have $75 that you can pay every month. Option B, that credit card has no interest in the first year, which means that the entire $75 go towards the amount that you owe there. So keep that in mind. Just look at the answer key to help you out if you're stuck. All right, thank you.